Yeah, good morning. Come in, please. You're very welcome. Okay, I suggest we start this session, which is organized by the science clusters. We'll get into detail about what that actually means. The thematic subtitle is Discipline Alignment and Interdiscipline Collaborations, Lessons Learned from the Clusters, so the science clusters. We will have a number of presentations, short ones, max 10 minutes, and then a Q&A, where we would love to hear your voice. So we won't have a discussion with among the panelists, but with you. Hope you can prepare your questions during the presentations already. We hope to have a lively discussion. You see here on the slide the panelists. I will introduce them later on as well. Need my laptop. Can I have the next slide? Oops. Hold a second. Hold a second. Okay, yeah. Yeah, it's all right. Yeah, so can I have the next slide, please? Let me first briefly introduce myself so that you know whom you're listening to. My name is Francisca de Jong. I'm the executive director of one of the ERICs, one of the research infrastructures in the European context. Okay, sorry, yeah. And Clarin is a research infrastructure for language resources. The ERICs together form a strong network together with a number of the other research infrastructures, and they have a structure among each other which stems from the structure that was imposed or chosen by ESFRI, the Strategy Forum for Research Infrastructures. In total there are 5 of them that collaborate as clusters, and they have a certain role in the landscape of research infrastructure, structural support for research initiatives and individual researchers and research agendas and all that. So they all have a thematic focus. They're not generic. They focus on what their community is needing in conducting their work and in fulfilling their mission. So everything that we discuss today, most of it can be interpreted as coming from a thematic background, a disciplinary background. The research infrastructures are providers of services. So they provide data, they provide tools, they provide workflows, sometimes access to publications, etc. But they also maintain a very direct link with the communities of use, with the researchers that they know best, sometimes by whom they have been selected to play their role. Many of these initiatives have a bottom-up history, and they run a number of disciplinary platforms, and of course all these platforms have been registered in EOSC, but these platforms are also consolidations of sometimes more than 20 years of pre-EOSC development, all based or mostly based on interoperability. So this layer of disciplinary collaboration, which is in the way we present it today, is rooted in EOSC projects, but it has a long history, also continued by ERIC Forum and ESFRI. So in a way, we have a life of our own, irrespective of what's going on in ESFRI, in EOSC. But of course, EOSC has provided us the means to collaborate within the clusters, but also to set up the collaboration across the clusters. And that has turned out to be very beneficial. So you see here an image where the 5 clusters are listed: ENVRI, EOSC Live, PANOSC, Escape, and SHOCK. And the individual panelists will tell you more about the work done in the clusters and their respective and the research infrastructures that they represent themselves. And this image was also meant to underline the fact that between the clusters, there are all kinds of nice initiatives for multidisciplinary work. So what do they do in practice? How does this collaboration take shape in practice? There are aligned agendas and initiatives. There are projects aimed at a common value proposition for ERA and EOSC. There are white papers, there's common web presence. There's alignment of thematic services across clusters to enable the multidisciplinary mission-driven work that is so important. I list here just one example, the project, the science project Meta-COVID, which is financed under EOSC Future. This is focusing on the harmonization of vocabularies across disciplines, in particular life sciences and the social sciences and humanities. It's meant to enable working with heterogeneous metadata for specific problems, especially related to COVID. And this is applied to parliamentary data, survey data, biomedical data, social media data, etc. So this is just one example of where the collaboration is taking shape. And it's all rooted in and made possible by the funding coming from the EOSC projects. But without further ado, I will now show you the program for the remainder of this session. So we will have 5 short presentations, and then we have the Q&A session that we, for which we would welcome your contribution. The first speaker will be Andy Guts, working at ESRF, and he's representing in France, and he is representing PANOSC.
Okay, the slides will come soon, I hope, but just to say that I'm representing the whole photon and neutron community in Europe today. So there were 2 projects in EOSC, PANOSC and EXPANS. And what I'll concentrate on not is what we've done for ourselves only, but what tools or what has been developed which was shared sometimes by serendipity, by chance, between the clusters, and others we went to look at what the others were doing in the other clusters to show what synergy we created between the clusters already through the tools. And then this is, of course, excellent food for the next round of proposals or collaborations. Even, you know, without money, I think these things have to be sustained with our own money. Where's, you want, I need... So yes, I'll be talking about the tools. Then the tools that we developed inside the photon-neutron community, which were then shared amongst the others. And they are mainly about visualization, processing. Then the training platforms, where we had synergy amongst each other, and also the DMPs. So we did an exercise this year, as all the 5 projects came to an end, where we went into, made a matrix of, in the different categories, what we would, each cluster had adopted or developed. So it actually was a very interesting exercise, and I think this one is just the beginning of something we can still exploit now. Because we didn't actually, there was interaction over the last 2 years, but not a strong alignment of the agendas except via the EOSC. I think in these, this table shows that there's a lot of things that we actually shared or that we could share. And so I invite you to look at the slides where you'll see the things that we've chosen. The message you'll be hearing here a lot, I think, from the other speakers as well, and you've heard already from Francisco, is that the clusters are not only consumers, they're also providers. They're both providers and consumers of tools and platforms. And so in many cases, we cannot just go to a new platform because we already have a solution, and this is very expensive to move from one to another. That being said, I will only concentrate on 2 of these little boxes here, which were the training platforms and then the work around visualization and data processing. But we could, of course, have a much longer talk about these other topics. So one thing we did was we worked on active data management plans. So this is something which is very important concept, which is in an attempt to try and make data management plans more useful. The data management plan is not only established at the beginning of the project or at the beginning of a proposal, but it is something which is updated throughout. It's a living document. So this is a concept which we used, and we used a tool which was developed by EOSC Life called Data Steward Wizard. I think it's even one of the developers is here in Prague, I think, or University of Prague. And this has turned out to be very useful, so that, we have now adopted it and deployed it on a number of facilities, 2 at least. And it allows us to manage the whole data management plan, filling out the questions, designing the templates for the different funders, for our own funders. The big thing is, how is this useful to the users? And at the moment, I would say the jury's still out. It has to be made more useful for the users to find the added value of working with DMPs on a regular basis. They're obliged to work with DMPs by certain funders, but we have to, this has given us feedback from the scientists, which we're now going to feed back into this. I think this whole discussion about DMPs is still a lot of work in there to make it something, a tool which people will say, I need this tool, yeah. Then we worked a lot on one thing where we invested. We had good full-stack developers to do visualization of data in the web. Because I don't know if we're all aware that a lot of things are moving to the web, but the tools are not always there. So we had to make a very, we looked around, of course, what tools were there, and there weren't enough tools, there wasn't the perfect tool there, as usual, but there wasn't even a tool which would allow us to display tens of megabyte images in the web at with a very good user experience. So we developed this, and actually what happened is that it's been adopted. It's been now available since 1 year, I'd say, as a stable release, and it's already been adopted by many different domains, because the visualization it's doing is of general interest. So it's an example of, even with something, you would think this visualizations landscape is all solved, it's all been done, and these tools all exist, and most people would say there's no need to put this into a project. This tool ended up filling a need which is there today, and we have people in neuroscience, in astronomy, NASA, geoscience, material science, companies that have adopted this tool simply because so much is moving to the web. This tool filled this need. And this is something where I think, these kind of projects can actually play a role, because normally you wouldn't have the resources to just build something which is for the whole world there. Then the other thing, I don't know if you remember the first slide, the matrix, there was almost everyone is using Jupyter. So Jupyter has become something that is it's such a standard tool nowadays that when there was a survey done by Nature last year, it was listed after Fortran and after the FFT, was listed as the 3rd most important software development ever, which is something which is quite interesting, yeah? And so this is something which we have thought, we put in our proposal from the beginning. It's something that we really have to support and encourage people to do that. So these 7 or 8 points here explain everything that we did to enhance Jupyter and make it a service at all the facilities. So I think it's something which we thought was really useful, and it's obviously proved to be useful to us. I think that the EOSC should actually be providing Jupyter resources if it wants to be a provider of resources at all, yeah? Because this is something which is so standard, yeah? And you have my binder out there, which anyone can provide resources to, and just help the whole scientific community, yeah? In the case of ESRF, we have over half the scientists are using this on a daily basis. So this includes scientists that are coming from outside, as well as our own scientists. Yeah. One thing that I haven't seen here again, and which was a big topic for us in the beginning, was making open science reproducible publications. So the idea of a reproducible publication is that you can actually execute the publication. So there was quite a bit of interest in this a few years ago, but I haven't seen anyone working on this today, or at least at this conference. And I think this is still a very important topic, and it's going to grow, that people will be publishing executable publications. So there's also a video, if you don't know what I'm talking about, there's a video which you can have a look, as someone showed how they actually used the Jupyter to reproduce reproduce the results of a publication. We've also developed with the ILL during the COVID. Everyone couldn't travel anymore, so we had a tool which was already started being developed, but was fully rolled out, called Visa, which is for remote data processing and analysis. And all the experiments have been done with that. And even if remote data processing is something that's very common, let's say remote desktops, this one went a step further to solve the issues that most of us are facing when we have external users using local software or local experimental equipment. The training, so of course, I think everyone has developed a training platform, but what we did is we didn't go so far as to do everything ourselves. We cribbed this one. We copied from TESS, from the Elixir project, which is heavily, I think, supported by EOSC Live. And I heard this morning at breakfast that this is going to be, there will be a collaboration which will be continued after these projects between the two sites, or the sites that are maintaining TESS here. To conclude, I just would like to say, I mean, this message is really important. As providers and consumers, we don't have as much flexibility as people who are only consumers. And we also see ourselves as part of the EOSC infrastructure, if you like. Even simple software tools are really important. I think they can make a big difference. And it would be wrong not to include them in future projects as well. Yes, and I think we, from that matrix and from our discussions over the last year, we have enough material, and now where we can actually create more synergy, because we're going to be active in working together. Yeah, that's it. Thank you.
Thank you, Andy. Then I'd now like to invite Andrew Petzold at the stage. He's an atmospheric scientist representing the environmental cluster and is the coordinator of ENVI-FAIR.
Thank you very much, Franziska, and thank you very much, Andy, for setting the scene very well with the matrix at the beginning, because the setting of my presentation is almost the same as Andy did, but I will give you a bit more insight on the ENVI cluster itself. So the landscape of the environmental research infrastructures is very diverse, because we are bringing together infrastructures which work in the 4 subdomains of the Earth system, in the air, water, land, and life areas. And all these are by themselves very heterogeneous. It means we need to bring together scientists from a very different background. So interoperability or interdisciplinarity in our domain is already working across the subdomain boundaries. That's the first step. So let's refer to what Andy said this morning. Let's learn walking before we try running. That's what we did here. First we want to walk. If you look at the numbers, I mean, you get the idea of the challenge. So each of the subdomains is composed of operational infrastructures with operational data portals, which serve already now a large number of users. And since all these elements are operational, we have set up systems now, and the big challenge in the ENVI-FAIR project and in the onboarding to EOSC is, for our case, to build an overlying structure across the ENVI RIs to bring them together in the first place, and then we can move to EOSC. And this is a big task on its own. You can imagine if you look at the number of involved players and the number of researchers served. We then looked carefully at who might be the users of our resources, and Niklas showed that yesterday already. So we need to serve various target groups like the scientific communities, and these experienced or specialized domain scientists, they will not use EOSC. They go directly to our resources because they know what they are looking for. And here we try to support them by setting up APIs and also to build up these cross-research infrastructure access via the ENVI Hub. That was to serve this group. The research infrastructures in our domain, they are also a group of users of the services. And here we provide the knowledge base to share technology, knowledge, and training resources across the various research infrastructures, still within the ENVI domain, but that can go beyond. And for one reason, to help further developing the landscape and especially new or emerging research infrastructures to not repeat the errors the others made, but to learn from the exercises. And that is something we are also share across the cluster. So maybe others may learn from the things we went through. And finally, the third target group is the users of EOSC. And they will access our services, hopefully, via EOSC mainly and the hub. And here we have the challenge to develop a rich metadata schema to guide them to the resources they are looking for. That's the concept. So for that, we developed what we call the ENVI Hub. That is a collection of services provided by the research infrastructures with a metadata mapping layer in between, which connects the resources to 4 or 3 main points key exploitable results, that's the name. So we have a web user interface which guides the human users to our resources by a search engine for quick discovery and for sharing technologies. We have a machine actionable interface, which is the catalog, to be directly incorporated into EOSC, and we have the Jupyter Notebooks as the main tool for research environments. So this is the structure of the services we provide within EOSC. That's how it looks like now. If you go to the ENVI Hub, test the demo, you will find various resources like the catalog, the knowledge base, the training catalog, and the science demonstrators. And I want to guide you first quickly to the training, because like for PANOSC, training is a key element and a really cross-cluster activity, and we developed a full training platform that was driven by LifeForge as a responsible research infrastructure, by running schools, webinars, and offering tutorials, and we also work on training, guided trainings to specific points. That's actually in the development and offering best practices. So this is open to everybody, and that was a big success within the development. And you see here one case for the what we achieved. So we were really supporting the EOSC EB Skills and Training Working Group by working into the report on the digital skills for fair and open science, where a lot of expertise was brought in. We are running the EOSC Future Work Package 9 together with others on training, and especially working together with the FAIR's FAIR project and the RDA Education and Training on Handling of Research. This interest group adopted the schema we have developed for our metadata. So that is really a big success, where things developed in ENVI FAIR were brought to the entire community. And also working with open air research coordinators of the community of practice. So we are really heavily involved to spread our knowledge beyond the borders of our domain. Oh, come on. One thing I can't go into detail, but that's something when we have launched the ENVI Hub, you can go there. As I said at the beginning, interdisciplinarity is already a challenge within the cluster. So we developed a set of science demonstrators based on Jupyter Notebooks, like, for instance, the FAIR ENVI Atmospheric Data Demonstrator. That is a tool which brings together all the data from the infrastructures in the atmospheric sciences, and you as a user can then explore across various RIs, driven by scientific questions. And this is now working, and we use that as a driver to make our data fair. That means when this interoperability runs, then the data are already fair to a certain level. If it doesn't run, then there are gaps. So we really use it as a driver. And the same on the ocean sciences by their essential ocean variables global product. They went the same way. This is established, and you can explore that once we have launched the the ENVI Hub. It's still under a test phase, but this is then available to the public via EOSC. As a kind of a continuation of the impact story, where we serve really the broader community that is within the RDA, we have a lot of engagement. So ENVI Ferristas are really involved in many of the groups, and especially I want to highlight two things, and that's the IADOP framework for the fair variables and metadata description driven by our community. And one thing we heard yesterday already in the World Fair presentation, and it was mentioned that morning to some part, is the fair implementation profiles, which were developed with the support of our cluster, and which is now a tool used by many groups. And the idea here is we started with a questionnaire related on the implemented FAIR principle as various levels. Moved on then to the digital objects that provide the functions, and to check who is using which of these fair enabling resources. And from that you come up with a fair implementation profile. And this is now turned into a product which is fully operational. And that's one example of a success story of the ENVI community together with CoFair and with Codevance. And Codevance is based in Prague, and they did all the coding work in the background. So thanks to the people making that real. And we use the FIPS for monitoring the progress throughout the ENVI Fair project, and that turns out to be a very useful exercise. I can really recommend going to the data stewardship wizard and the FIP wizard and exploring that. I skip this. And the last thing I want to mention is here with the open science. So open science is embedded in the genes of the environmental research infrastructures because environmental data are of public interest. So we give our data free since from the beginning. Luckily, we have almost no sensitive data. So that's different in social sciences or in life sciences. And so we have built an open science community around the research infrastructures already individually, and so in that sense, going the step to open science is a quite natural movement within the ENVI community. And I want to finish with a view on our journey. So I mean, we started with a very diverse community, or distributed community, and we had to go through different obstacles and construction sites with identifying gaps, defining implementation plans, implement the things, getting the ENVI Hub dumbing with the COVID-19 and other things interrupting the work. We are on the way. The journey is not an end yet, and that's my message as a lesson learned from the clusters. The journey to fairness will never end. We need to be aware that it's not sufficient to get things together one time. We need to maintain it. We need to further develop it, and that requires resources, which comes on top of our scientific questions. This is something we really need to transport also to the funding agencies. At the end, I think the journey was quite successful by getting things together. Our destination is the society, and EOSC is a vehicle, one of few. The destination is not EOSC. It's a thing we want to use to reach in the heart of the society. That's it from my side. Thank you.
Thank you, Andrew. Then the next speaker is Niklas Blomberg. He is the director of research infrastructure Elixir. He representing or part of the life sciences, and he is the coordinator of a number of cluster projects currently running EOSC Live and by COVID.
Thank you, Franziska. And like the other speakers, I'm here on behalf of the community, and there is actually quite a few representatives of the community here both in the audience and I think at the conference, so please approach them. When we started to think about EOSC Life, we wanted to find ways of bringing together data across the 13 different research infrastructures in the life sciences. And I mean, we are all research infrastructures. We are here to serve users, and we have instrumentations and facilities that are user focusing. And I think we really, what we wanted was really to sort of connect digital life science data to address sort of major challenges. And we thought about interdisciplinarity as a way of connecting data across the facilities and across the experimental techniques that we have in the life sciences. That built on experiences from previous cluster projects. So in the predecessing project, which was called Corbel, we did a lot of work on how we could manage transnational access for users that wanted to have multiple experimental techniques so they could get a review of the project and don't have to get it reviewed by every research infrastructure 3 or 4 times, but really sort of apply as a package and then get guided through the experimental techniques. And from that, we realized that we need to also to look at data. And so, because research infrastructures are important, they sort of democratize science. In Europe, you should be able to run advanced experiments, even though you might not be at a university with a very large core facility. But if you're then remotely accessing these tools, you also need a way of accessing and computing and analyzing your data, and the cloud technologies seemed ideal for that. And so really what we wanted is to develop solutions so that the scientists could access and analyze their data and make use of the data, the tools and the workflows in the cloud independent of where they were located in Europe. So really trying to sort of support the transnational access schemes of research infrastructures. And of course we do that, and we believe we could align with a number of the missions, and we looked at the missions and how we could support them, and then along came COVID, and so that sort of took the center stage of a lot of the work for our clusters, not only for the infrastructure I'm leading, but really for all the research infrastructures. So that's been a big driver for the project. Like all the other projects, we set out and wanted to work in a number of different domains. And I think the people domain, Andreas just talked about the training, I think is really important. The skill, the capabilities, the networks between the infrastructures and the training platforms was really one of the sort of big investments. The icons are a little bit small, but there is a sort of a training icon associated with almost every work package here. As I said, we wanted to build on our experience and really consolidate the processes for research infrastructure service delivery, so it'd be easy to get users going between the facilities. We wanted to look at the data resources, like all the other clusters. We've built up data catalogs and standards catalogs and so on. And we've done that within an established resource fair sharing. And I think that's a principle we adopted throughout the project, is not to build very many things from scratch, but really identify already running community resources and invest in those and make sure that they can be sustained and taken forward. And I think I talked about the training materials. Policies and guidelines for sensitive data is really important for us, especially for the medical research infrastructures. We have delivered a number of exploitable results. This is coming from a brochure and the websites, and I'm not going to go through of them, but I think this is what mapped into the very nice table that Andy showed, and I thought that was a really interesting experience, actually going through all the clusters and see how well the solutions map together. So I just want to highlight one of all of these results, and that's what we call a toolbox for sharing of sensitive data. And so it's bringing together a lot of different guidelines and training materials and procedures from the various research infrastructures, and been tagged in a consistent way. And so this is currently in beta, but the idea is that you should be able to go to this website and just type in your question and be able to find the relevant guidelines for cross-border access of human research or data from human research volunteers, I guess is the word. The project has been really driven by users, so we wanted to construct the whole development around the open calls. And so in total we've had 3 open calls for different types of partnerships. We have looked for making data fair partnerships, and that was targeting the national facilities of the participating research infrastructures to make sure that we get their catalogs incorporated. We've had direct user projects, and we've also reached out to companies and try to partner with the companies around open data, open science. And in total, there is about 27 projects that we've been working with throughout the lifetime of the EOSC Life, and I think that's been really interesting. And then came this pandemic, and so we got a number of 3 extra work packages with additional top-up funding specifically to address the COVID-19 data platform, but also to build and maintain the repository for clinical trial data coming out of the myriad of clinical trials that were run around Europe. So on the user projects, I'll just a few. I think they fall very neatly in sort of 3 categories. So we have a number of projects directly with the facilities, but also most of them are actually coming from users of the facilities, looking at how we could make better workflows and adopt the workflows in between different research infrastructures. For instance, the genomic observatories from the marine outstations, and there is work on imaging data sets and so on and so forth. We've also had applications from communities that we hadn't really had visibility of. They haven't really been sort of users of any of the facilities. I think this is a really nice example. I highlighted yesterday as well. We have a few more. But this is a small community of historic botanists who are looking at microbodies from plants that they are preserved in earth. And so they're building, of course, data repositories where they have sampled this to understand what was grown in the 14th century in Middle Spain and so on. And you can get that out from those silica bodies. And so we're working with them they have a big drive in that very small community, but very rich data, and to sort of make a community common database based on the FAIR principles. So we provide a lot of support and training to them through this. And then with companies, I think this is a really interesting one. Björn Grüning from Freiburg, it's the Freiburg team who's been leading on this, with a small company on detection of DNA, so identify foodborne pathogens. So they are providing that service commercially to users, to cities or restaurants or whatever. And they've been working with the partners to take their whole analysis pipeline, make that open source, publish that in the cloud, because they realize that there is no benefit for them to have a proprietary pipeline. The added value for their customers is really in their analysis. And so by moving this to a modern architecture and opening that up, they could benefit from more developments that are happening in the larger scientific community. So I think it's a really nice example of how you can work with industry and in an open science context. So as I said, COVID has been a big use case, and I think that what it did really validated the pipeline, the sort of tool set that we brought out for managing data between the different facilities. And I think rewardingly, we've seen that tool set now being adopted in a number of EOSC projects. So by COVID, I just showed EOSC for Cancer, also in Neuroscience Gateway, but it's also being used in these transnational access projects. So these are infra-IA calls, so the transnational access of users to research infrastructure facilities, and indeed our partner RAs are using the toolkit now to serve the users in practice. So I think that's a really good development. So I'm going to end there, and thank you very much for the time.
Then I would like to invite Ian Bird to the stage. Ian is a particle physicist at CNRS in France, and he's the technical director of the ESCAPE cluster project.
Yeah, so I'm here representing ESCAPE, which is a community of astronomy, astrophysics, particle physics, and nuclear physics experiments. And what you see here is pictures from each of those. These are very different communities, even though they're all physicists at some level. Mostly ESFRIs, and some are new. And the reason for coming together in this cluster was because we were facing some common practical challenges which were related to the data volumes that we have to deal with. So several of our infrastructures are having to face the challenge of multi-exabyte per year data sets. And indeed, the other of those research infrastructures are at the scale of many petabytes or hundreds of petabytes of data. So we all had a common challenge. So that was the thing that was really pulling us together to address that. However, it was conceived, ESCAPE was conceived as a sort of mini EOSC from the beginning. And that's why you see it sort of clustered around the data infrastructure, which we have called a data lake. Unfortunately, if you look up the Wikipedia description of a data lake, you see something different. That's not what this is. And I'll describe it in a second. And I reiterate a point that was made earlier, that the users don't want to see any of this stuff. They want to see their own workflows which are coming from their experiments or their communities. They don't want to have to worry about what's underneath it, whether it's from ESCAPE or whether it's from EOSC. They just want it to work. So this data infrastructure, which we call a data lake, is a federated infrastructure because at the scale that we're at, there's no single data center that can afford to store all of this data. So we have to store it as a collaboration. It's federated through a common AAI. This is now federated with the EOSC AAI. And what it does is it implements FAIR. So it at least implements the F and the A as it is today. Data is accessible, it's findable. The thing is that there's a policy engine. So there's a policy for managing the data lifecycle, there's a policy for managing quality assurance. You could, in fact, add a policy to guarantee that the data is interoperable. Today, that's not there, but it could easily be added because everything goes through this policy engine. And as was said earlier, the reusability part comes from the fact that you can access it and it's available. The other thing I think, which is not really discussed very often, is it also implements sustainability. Because it's a federated infrastructure and because there's a policy for how many replicas of the data you have, you can unplug data centers from this and you don't lose the data if you've set it up correctly. So actually, the data can be there, actively reviewed, actively managed, because long-term sustainability of the data isn't just putting the data on a shelf, you actually have to do something to make it available. And so it can deal with that. As I said, it scales to multi-exabyte. It's got mechanisms for serving the data to you in your notebook or to a compute cluster, and it hides the complexity. All the user sees is a single endpoint to get their data. I mentioned AAI. I would just reiterate how important AAI is here, because I think if nothing else comes out of this, having a single AAI across the community is really important. And this started as a community effort, bottom up, many years ago, which culminated in the ARC blueprint architecture. The ESCAPE AAI actually implements a sort of hybrid, because we need to manage our legacy infrastructures, which are based on X509, as well as moving to the new token-based infrastructure. So that's in place and that's working. So it means that we can couple all of our existing infrastructures into EOSC now. Away from the data, we also have quite a lot of effort around software development, software management, training, and so on. And so we have a software catalog, this open source software and services catalog, which has a number of different aspects. It's not just the catalog of the software that we develop. It federates, again, across all of the research infrastructures which are in ESCAPE. It's designed with the long term in view. It's integrated already with EOSC. And coupled with this activity, there's also a significant training activity. So we've run a number of software schools, which is not just training people in the tools, but it's training people in how to manage software in the long term and all of these aspects. And actually, due to the lockdowns, this became hybrid schools, which were attended by several thousand people in the last iteration. So they're really popular, and that was a huge success. So the catalogs and the data, so we have three sort of high-level objects. There's the software catalog and service catalog, which I just mentioned. So this has already been onboarded into EOSC. You can see it in the EOSC Explorer there. And this is a scalable way of doing this for Escape. So the Escape products that we put into that catalog are now automatically visible in the EOSC marketplace. In terms of data, we have two high-level objects. One is from the astronomy side, which is the virtual observatory. Now, this is a portal of data and tools and a lot more besides. And so rather than try and reproduce that in EOSC, this is onboarded as an object so that we retain all of the community knowledge and the benefits that have been built up over many years, but it's also available to everybody. And the data in astronomy has been historically open with their data, so this is a natural evolution of that. From the particle physics side, we have what's called the High Energy Physics Open Data Portal, which has been developed over 10 years or so. And again, this is a place where you can not just find the open data, but you also find the tools to use that data. You can find example notebooks, you can find tutorials, you can find the software. And both of these, the Virtual Observatory and the Open Data Portal, are both complete services, and so they're onboarded into EOSC as portals. I just mentioned here two demonstrator projects which are really cross-cutting science across all of the infrastructures which I mentioned in Escape. So one is on dark matter, and both of these actually are sort of grand challenges in astronomy and particle physics. One is on dark matter, and the point here is that a lot of the research infrastructures in Escape have experiments looking at dark matter in different techniques. They vary in the data sizes from a few terabytes to multi-petabytes. The advantage of using the Escape infrastructure is all of that data can be brought together in the same place. We can have a common analysis, we can have sharing of data, we can do a lot of things that weren't possible before, and this is more or less transparent to the users, and actually this afternoon there will be a demo of using this. The other one is what's called the Extreme Universe, and this is really setting up a sustainable infrastructure for multi-messenger astronomy, where transient signals from one type of telescope trigger observations from others on different timescales, ranging from a few seconds to days or years. So this is important to have an infrastructure which is capable of doing this and sharing the data at the same time. So we use the data lake for that. This slide is just sort of illustrating a little bit how this is integrated together, and the workflow that you see on the right-hand side there is what will actually be demonstrated this afternoon. I would just mention what we call a virtual research environment, which integrates all of the things that I've talked about and many other things besides. So from your notebook, you can actually access data directly from the data lake. It just appears as a list of data sets which you can search. This is then provided as, you can take the software from the software repository, you go through the Escape AAI, but it's actually federated with the EOSC AAI. You can produce a result, which in this case is a plot which combines data from many experiments, and you publish those results out again. And I would just also mention one other thing here, which we also don't really talk about when we talk about open science, which is open access journals. And I think particle physics was one of the places which really drove the move towards having open access publishing of scientific results. And I think that is something which we mustn't forget. In terms of the long term, we have decided that it was such a good idea coming together, we will continue after the end of the funded project. So we have a new collaboration agreement. It's been signed by all of the existing partners. And it recognizes that there are really many, many synergies that we found across our communities, not just technical, but also political and funding issues. And as was said before, there's clearly common positions with the other clusters on lots of these topics. So that will be an ongoing collaboration, we hope. So just to finish on what ESCAPE brings to EOSC, so it represents a broad set of communities. We have significant technical requirements and expertise, particularly exabyte scale data management, which has been accumulated over the years of LHC, for example. We also have a lot of experience in managing globally federated compute infrastructures and making that reliable to the extent that our users really don't know that that's what's underneath what they're doing. So I think we also have a lot of experience and expertise in collaborative software development as well. So I think, you know, a number of these things are clearly cross-domain and really important for the future of the EOSC. So these, I think, some of the things that we should mention, and there we will finish. Thank you.
And then I now invite our last speaker, Jennifer Edmond. Jennifer is a digital humanist at Trinity College Dublin, and she's a member of the board of directors of DARIA, one of the ERICs in the social sciences and humanities cluster. And the project for that cluster was called SHOCK.
Thank you very much, Francisca, and thank you, everyone. To talk about shock, I think I'm going to take a slightly different tack from some of the other speakers, perhaps. But I think it's actually really important to remember where shock comes from our point of view. The social sciences and humanities, it sounds like one great big happy family, but it's actually quite a diverse and very heterogeneous and a number of sort of, I want to say, I don't want to use the word fragmented, but I'll use the word atomized, because it is not that there is one big thing that has broken. It is merely that there is a very wide variety of approaches within that umbrella. So we anchored the SHOCK project with the ERICs in the area, the Social and Cultural Innovation ERICs. And even there you can see the diversity. You have DARIA ERIC, which is a broad-based ERIC for the arts and humanities, Clarin for linguistics, but also then some of the very survey-based or data-based infrastructures in the social sciences. But to go beyond that, it's important to look at the partners around those ERICs, because this is where you get that very, very strong impulse behind the consortium that we're actually bringing into the next phase now. So around these anchoring ERICs, we had two partners who were there for stakeholder engagement. And for me, one of the most important inputs into the SHOCK consortium was the contribution of LIBER, the Association of European Research Libraries. And this is where, as we move into the era of the data spaces and the European Cultural Cloud the European Cloud for Cultural Heritage, we're going to see more and more how that cultural data needs to be brought into the EOSC ecosystem. And I think we started a lot of that conversation in SHOCK. Then, of course, we had the research communities. The other speakers have already spoken of how community involvement was very important, and we brought this in from the very beginning, bringing in various communities to deliver these kinds of science demonstrators. And then finally, we had three partners who were delivering more on the level of the technology platform. So we wanted in this project to build this SSH Open Cloud. And that is something which is realized now within the SSH Open Marketplace, which I'll speak about more in a second, but also in the many components and the many data sets and the many demonstrators that were built around that. So maximizing the data reuse, I mentioned the important role of the Consortium of Research Libraries, and also to interconnect the existing and the new research infrastructures. And again, that's something I'll come back to, because I think when you speak of sustainability of these clusters, we need to think not just the sustainability of the assets we produced, but also the sustainability of the networks, the momentums, the integration that we were able to achieve. So we also wanted to set up this appropriate governance model. And again, that's something to come back into in a second. So the SHOCK project itself, and I think we were the first of the cluster projects to complete our work. We closed the project in April of this year. The SHOCK project itself as a whole had a total of 25 key exploitable results. I won't go through all of those today. I will give you some pointers as to where you can learn more about them, though, but just to give you a general overview of the kind of work that was done. Again, as the other speakers have said, training was really important. And I think there's a really good reason why training has come up again and again in these presentations this morning. Again, I'll come back to that. There's going to be no presentation left by the time I get to all the things that I actually think I'm going to get to. Then there's also the fact that we have this marketplace. Findability of tools is actually a real challenge in this heterogeneous landscape, and that was one that we wanted to address with force and with conviction. The availability of cloud-ready SSH tools and data was also very important. Again, there is this lack of fair by design data out there, so we needed to move forward with that. And then finally, the mechanisms for trusted and secure access was another of these sort of overarching areas that we focused on with these 25 key exploitable results. Now, as I mentioned, because the project has finished, I can point you to some very good resources to learn more about these results. And in particular, I would point you towards the service catalog there on the right-hand side of the screen, which will let you find all the results and all the things that were developed in the project. But also, I'd highly recommend you take a look at the legacy booklet, because this is where you'll get a much richer view of the impact the tools had, what was developed, and how they're being used going forward. So these are two assets I can really recommend to you. But when I was asked to do this presentation, I realized I could come back to one of my favorite slides, potentially of my entire DARIA career, which is this slide looking at the, it's actually the next one I really like, looking at the way in which these science clusters helped us as ERICs, as organizations working within the wider EOSC ecosystem, to understand our position and our contribution as distinct and different from our home organizations in the ERICs themselves, but also from the EOSC and the sort of the upper level integration infrastructure. So if you think about it, again, it all comes back to the researcher, doesn't it? It all comes back to the fact that we need to have scientists accessing this infrastructure to create their results. So if the scientist is looking for data, then in DARIA, to give the example of my own institution, we can provide a sort of specific instrumentation for that. But the interdisciplinary integration really happens at the level of the clusters. And this is what we saw again and again in SHOCK. It was this intellectual middleware, not the software to tie things together, but the ideas, the understanding, the standards, the integrative conversations to bring things together that happened within the SHOCK project and didn't happen anywhere else. And then, of course, that relies on the stable, interoperable, durable, and dependable tools. And this really reminded me, listening to Andy's presentation, about the fact that the clusters are both consumers and users. And you can see from the way I present it is that we're reaching forward and upward into the creation of these very generic tools, but we're also reaching downward into the communities themselves. And if you bring a literature scholar to a party, you're going to get a metaphor. So I always thought of this as, if you want toast, because everyone likes toast, you really need all of these elements to go into it. You need to have data. You need to have the instrumentation. You need to have the integration, but you need the standards as well. So you need everything from the loaf of bread up until the electricity grid. The more we can think of the European Open Science Cloud as an ecosystem and not a place, the better we'll be prepared to actually take advantage of it. And I think the experience of the clusters is really what brought this home to me. A final slide on sustainability, because this is, I think, something that's very important. It's very easy to have a funded project and then at the end of the project not have any time left to actually use the tools, right? And it was interesting that Ian, the last speaker, was saying he as well was representing one of these clusters which is looking towards the sustainability. And again, I think because we closed at the beginning of this year, we've had a fair amount of time now within SHOCK to think about, well, how do we continue this legacy? How do we actually enliven this fact that the journey isn't over? Infrastructure is never like a mountain. You don't get to the top and say, right, we're done. It's a river. It's constantly moving. So how do you keep on top of that? So we've really broken this down into a number of different levels. There are a lot of tools that were developed in SHOCK that are most relevant for specific communities. Key for their work within the EOSC, but relevant for those communities. And those tools are being sustained by the specific ERICs or by the specific owners of those projects. And that is the most relevant, the most fair place for those assets to be. Then we have things like the SSH Open Marketplace. And for me, as someone who's been working in research infrastructure for a long time, to have 3 partners come forward and say, yes, we are going to fund together the continued development of this project because we all believe that this is a valuable platform for our users, that says a lot about the value of what we built and the value of our work together. So the SSH Open Marketplace will be jointly sustained by ourselves, Daria, Sesta, and Claren going forward. And then finally, however, that wider integration, the network, all of that tacit knowledge that we developed also deserved a place to be sustained. And so we also have this SSH Open Cluster. We figured we'd keep the acronym. And we're actually working actively since the beginning of the year to both consolidate the questions around how we work together, but also to make sure that we continue to sustain the relationships, the dialogues, the interactions, the interdisciplinary conversations that we began. These are things that you can't actually just put on a server and have them continue to be available. They have to be kept alive. And that's what that consortium model is doing for us. So we're just finalizing our internal rules of procedure. We signed the MOU at the beginning of the year. And I really think that this is actually one of the key things that we can actually contribute to this conversation is how we continue to have active clusters going forward and how we continue to have that essential piece in this swoop towards from the researcher at the most granular level up to the very shared services up at the top. Thank you.
So now we have a bit more than 20 minutes left for the conversation and the exchange with you in the audience and the audience that is following us from other places. There's a slide here in the room for those of you who are not here where your questions will be projected. So I'd like to invite the panelists to the chairs, but I would like to hand over the microphone, or the microphones, to you in the audience to ask questions about our plans, the lessons learned, the obstacles, the tensions in the various agendas that we have to follow. For now, it's up to you. Yeah. Okay. I see already several hands. I think the person in the middle. Yeah. Please mention your name before you ask your question.
I'm Volker Mehmann from the European Mathematical Society, and I want to ask the question I heard several times: nobody should be left behind. But the difficulty is that within these clusters, big projects were made. How about the smaller communities or not so data-rich as physics or astronomy or life sciences? How do we bring them in a good way, either into clusters or into the EOSC environment to also get the FAIR principles better situated in these communities?
Okay, who would like to respond first? Ian?
No, it's a good comment and question, because I had that exact same discussion with Anna, I think, or during coffee we were saying that the same is where, if you're not part of one of these big projects, where do you go and get help now? And actually this kind of community help doesn't really, at least I haven't seen where you could go, at which door you could knock. Everyone's working on some objectives which have been set up in a larger proposal. And my comment would be, we need this. My own experience is from open source software, so I don't know if we can somehow set up a community kind of portal mechanism where people who have questions about this or need help can meet the other people who've all been working on these projects and now have this know-how. Yeah? But it's at the moment I don't see anyone proposing something like that. So I think this need is there, and we should work on something. Yeah.
So in EOSC Live we had the open calls which were really bottom up, and I think these bottom up calls as part of EOSC is really an important component, because we had, I mentioned briefly the phytoliths, so the botanists from historic England, but we had other examples as well. And I think that will have to be the mechanism, some sort of bottom-up call mechanism. And I think the most interesting part of that open call process was actually not the projects that were awarded. So we offered services to all the applicants to help them to write better applications and sort of mature the project so they would fit with the capabilities that we offered, because there's no point applying if there's a poor fit between the projects and what we do. And I think, and there we supported a much larger number of sort of potential applicants, and I think that was really interesting. So I think by structuring these open call type procedures well, I think we would have possibilities to reach out to the many, often quite well-organized but small research communities that aggregate around a specific problem or a specific data type.
Yeah. Maybe it's also good to mention that quite soon there will be a call to which the clusters can respond collaboratively, which comes with quite a large budget for cascading grants that would also allow smaller communities to join in. And maybe a side note, but I would like to mention that the distinction between clusters along the dimension of how much data there is maybe not the most useful one, because there's a lot of diversity, and in, for example, social science and humanities, we may have less bits and bytes needed for data, but the number of data types, for example, is enormous. There is the multilinguality dimension, the multimodality dimension. So the complexity is enormous, and therefore the cluster can play an important role in pointing people to the right places. But let's not go there too deeply now.
I would just add also that the cluster projects were set up explicitly for the S3 infrastructures. Now we've moved from the project to a more long-term collaboration. We're very open to other groups to join the collaboration. So.
Okay, there were other people that raised their hand. Could the mic be handed over? Yes, Sarah?
Yeah, that's me.
Sorry. Your hand.
Francesca.
Yes, please. Okay,
that's me.
Yeah.
Christopher Van Diedes, Live Eric.
Yeah.
We know that the dialogue between the clusters goes on since they have been founded. And we know that this experience has been intensified during the ERIC Forum project. I would like to know if there are any plans for the development of a roadmap towards the continuation of this collaboration, and how these plans you think that will be materialized in the near future. Thank you.
Thank you, Christos. So from the science clusters coordinators, we agreed quite early that we want to continue this collaboration and that platform beyond the clusters project, because from own experience, I have to say that it turned out into an extremely efficient and also, I can phrase it as very entertaining collaboration, because we have developed a good level of understanding moving in the same directions. And I remember the first meeting when we were surprised how closely aligned we are already with our expectations without speaking to each other before. And that turned into something which is really heading out for a sustainable long-term existence. So far, we have not yet agreed on something formalistic, because I think that's probably not really necessary. But we have a couple of ongoing proposals which may come up where we will be connected together anyway. So this may serve as one long-term platform, and also we have a good, let's say, consortium to talk to the Commission as clusters. I mean, the mandate for now comes, of course, from us being coordinators of the cluster projects. That's something we need to discuss, how to change this mandate once the cluster projects are over. But this is ongoing discussion. It's from my side.
So there is actually a white paper that was written by the 5 clusters together, which is publicly available.
And individually, the clusters are working or have been working on MOUs to ensure the collaboration within the clusters, which is also not something that was foreseen at the start of the model of collaboration. Yeah, Niklas?
Just one thing to add. I think we have been looking at some of the challenges running these projects up until now. I think what we haven't done, I think, would be very productive conversations in the future, and it doesn't necessarily need to be restricted to the project coordinators, is really how we start to act on the many commonalities that we've seen between the clusters. So, I mean, with PANOSC, we see there is a lot of work around imaging that cuts across the research infrastructures, both in the life science and in the PANOSC cluster. There's, of course, the whole environmental biodiversity field. You know this better than I do, Christos. And I think we see a lot of technical commonalities now as the projects are starting to mature and come to an end. And I think that's the next part, is really to see how we can bring together the experts that have been working on, say, analysis tools, or that have been working on metadata standards, because there are these very, very strong, both sort of philosophical but technical commonalities between the clusters, where I think we'll have a very productive exchange. So I think that's going to be the next wave.
Yeah. And maybe also in relation to the dynamics within the wider ecosystem and the eternally evolution of buzzwords. So at this event, the notion of data space has been mentioned much more often than at previous editions of this kind of event. So we see ourselves as the basis of the EOSC Data Federation, because we all have built data and have shared data, have models for federation of data services, etc. But we need to position ourselves again towards this new. It's not so much a new concept, but it's the new rhetoric that is emerging, and it needs to be clear for everybody where we are, where we stand, and where we want to go. Yeah.
First here, you should be able to. Yeah. Hello, my name is Margot Bagea. I come from a university, and so we are part of some of the EOS projects, and whenever we involve our researchers, it really makes sense to them, and they also work in that direction that we want to reach: verification, collaboration, and an ecosystem of research where collaboration is the new normal. And then I look at our conventional research assessment and the way that research performing organizations are often run. And it seems to me that they don't really create incentives for researchers outside of the influence sphere of our cluster projects to really take part in collaborating open science. And are we doing enough to work on this level, on bringing the research performing organizations into really incentivizing and rewarding researchers that are willing to take up the additional work in order to get into this mode of working?
I think this is very interesting to do an analysis of our relationship with the various stakeholders. So yes, Jennifer.
I think that's a great question. It's really important, and when you hear the discussions around, well, okay, so we need to see the use cases. This is what we want to see to make sure the EOSC really is successful. And when we have these barriers in the middle, where, for example, creating an open data set is not rewarded the same way as creating an article when it takes the same time. So I absolutely, with my researcher hat on, see your frustrations. And of course, this is something we've been talking about since I was on the Open Science Policy Platform, which was 2017, I think, as we were working on this. So it's not a new question. My hope is that with this new initiative within Europe around research assessment, the COARA framework, which is just actually in the process of being established now, that we will actually see incentives from the top and from the bottom for the researchers, but also for the institutions to revise the way that they are developing the proxies that they look at for research quality, that they're not just counting articles, not just looking at journals, that they're actually looking at the research work, at the research processes. So the language around this has been developing for a while, and I think we're right now at the tipping point where it's going to be able to start moving down into the institutions. At least that's my optimistic, my optimism speaking. But I think we all have to be aware of that. We all have to actually advocate for that, because it is really important that the next generation of scientists are empowered to actually do work the right way, not just do what their predecessors did.
Can I? I think actually the problem is broader than you explained. I think. And in fact, this is one of the things that we called out in that white paper as something that we really want to address. So the whole issue around rewarding people for working on software and computing rather than producing the science paper. This is a real big issue in all of our communities. This is one of the things that we found was really cross-cutting across all of us. And so this is something we really want to act on in the future together as the clusters.
I could just add experience from my field where I see what's growing is, starting to happen is the notion of data publications. So you only publish the data and you get credit for having a data set out there, but which has been verified as being of a certain quality.
Peer reviewed.
Yeah, and so I think, and this was one example I showed this morning, and I think this is something which could be rolled out more and is a way of getting official recognition that you've made good data, or that you've contributed to making good data. But what I see is unfortunately still happening is there's still not a big uptake in citing data DOIs. At least in our community, it's still ridiculously low. And I think there we still need some more push, and maybe through these new assessment mechanisms that people will be gaining this, that'll be a reflex. Yeah.
There was one more question in the room, and I also see some questions in Slido. So if we take your question first, then we can maybe pay attention to one or two of the questions in Slido.
Tiziana Ferrari, EGI Foundation and EGIA's project. The data spaces were mentioned a few times during the session, and something I've seen in industrial data space initiatives is a stronger focus on the concept of data exchanges and transactions, meaning enabling exchanging of data across communities and stakeholders. And in the presentations we had today, there was a strong emphasis on the service component and perhaps a bit less on the data. How do you see this being relevant in your clusters? How do you think EOSC should enable this data economy in science? Is this something you will pursue in the future?
Who would like to take the floor? Yeah, Andy?
Andy, go ahead.
I think the data, if it's good quality out there, they can migrate or be used from the data spaces. But I'm not sure what the data spaces are, just ignorance on my side, what they offer. I see an example in the example that we show with a human organ. It's Google who's helping the scientist. I don't know if the data spaces will have the resources to help the scientist as much as Google. I'm just thinking there'll be cases where people will just get other big commercial companies to help them, yeah? So it has to offer something which will be sufficient. I think there's no problem using the data in the data spaces. Yeah.
I want to add on that here from the experience in the environmental sciences that so we discussed at the beginning also or in the beginning of the journey the roles we will have, and the data are our key assets. So without data, the research infrastructures are nothing. That is what we provide to the scientific community. So we collect the data, we ensure the good data quality, we make them findable, accessible as much as possible, and then I can speak for the Argos research infrastructure, we make them accessible to everybody worldwide, to all scientists, whoever wants to work with the data can do it. So this is our key reason for existence, and we are assessed by our funders against the use of our data. So, I mean, we will not give away that. So the data will stay at the research centers and the research infrastructures, and we are all responsible for the curation individually. But then on top, for the use of the data, I mean, then it comes to the point where EOSC may play a role by making the data more fluent to the users, whoever wants to use them. But in our case, and okay, we do not deal with these big data sets you do at CERN or in the Panos research infrastructures. Here we have these individual centers and management systems, and I think for us it will stay like that because, as I said, this is the reason why we are existing.
I did mention the data spaces, so I'll just say that in the arts, humanities in particular, and social sciences to a certain extent as well, we have a very distinctive challenge that we don't necessarily own our data. We haven't created it. It was created maybe 20 years, 30 years, 100 years ago, and it's held by an institution that is specialized to make sure that that data is preserved and maintained. So there's a very different relationship there. Within Daria ERIC, we've been working for years trying to move towards something we call the Cultural Heritage Data Reuse Charter. Claren was also involved in that initiative because this data fluidity is a real challenge. If the data spaces and the museum cloud can actually do some work to enhance that, that will be a huge, huge boon for us, and in particular for our communities in engaging with the EOSC, because that data fluidity is a real barrier.
So when we started EOSC Life, we came up with a perhaps more clunkier term of a digital collaborative space for life sciences. Maybe data space is more snappy, but really I think it comes down to the elements that we're seeing in the data spaces. So one is to making sure that we catalog the data effectively, make it fair, but most importantly, findable and accessible. And then that we encourage the sort of innovation around software, algorithms, tools, and workflows so that people can actually do interesting things with that data. And I think that transaction bit is really central. So if we look in life sciences, a lot of the work is centered around the use of Galaxy, the European Galaxy server. Some of that is taken now forward in Euroscience Gateway. But it's really about how do you connect these different data repositories to a suite of accessible analysis tools that can be used by a larger community. And I think that's really at the core of what you could call it a data space, but it's really at the core of making use of that scientific data.
Yeah. Okay, then to be a bit more inclusive, I noticed 3 questions coming in. Am I right? Yeah, 3, I think, during this session from the audience elsewhere. Let me read out loud. In this symposium, we had 2 main tracks. So not this session, but this symposium. Science clusters, many RIs anchored to users, on the one hand. And second, building EOS mainly by few groups. Is this the wrong, is it the wrong way around? Of course, with 2 groups, the question is, how should the balance be between generic service providers and thematic service providers? At least that's my translation of the question. Could somebody take up that question?
Well, maybe not the whole question, okay. But I think the only way to build something which lasts for any reasonable length of time and is usable by the communities is to work with the communities to solve real problems. I think if we do this in a vacuum without the real use cases of the communities there, it's a waste of time. So I think that there has to be this interplay, and it has to be driven by the real needs of the communities. And so I think that I think the communities have to point the way as to what needs to be done. And my experience in the past, in when we put together the LHC computing grid, was exactly that. We had a lot of good ideas that we thought were things that people would be interested in, We pruned those away over time, and we were left with a hard core of things which were really useful. And on top of that, we developed a whole lot of new stuff. So this is a continuous evolving process, but it has to address what the communities need, and it has to be responsive to those changing needs, because the communities don't need something today which they last for 10 years. They need something different tomorrow. So we have to bear that in mind as well.
Jennifer, you may say something from the perspective of the intellectual middleware here.
Yeah, it's exactly that, isn't it, Franziska? Because it is a question of the move from the researcher up to, you know, the organization that is maintaining a single sign-on. You know, I as a researcher, I need access to large corpora of literary data. And because I have an infrastructure hat, I kind of know how to build that, and I kind of know how to deliver that. That's not my researcher hat, that's my infrastructure hat. I can't build that single sign-on. We really need all those different players to bring in the components. And there's also a vertical element as well, because there are times when you need the investment to build something, and there are times when you need the investment to maintain something and to disseminate it and to kind of propagate it. Those are different sort of kinds of investment. Those are different layers. So you may need different structures to deliver them. So actually, I think the ecosystem as a whole will require many different players. And I think there was another question about whether the science clusters should be building the EOSC. Well, we are building the EOSC. I think that's one thing this session has really shown, is how much of the instrumentation for the EOSC is coming from the science clusters. But we can't build all of it. We can build certain parts of it. And that's where we really have to be very mindful of how the parts interact and make sure that the parts continue to interact, but also recognize that we will need different kinds of parts, different kinds of players for different kind of contributions. The ecosystem's too big for one kind of player to do it alone.
Okay, thank you. Yeah.
A short add-on to that. I mean, just think about the wording. So we have the science clusters, and as the science clusters are built by scientists, and the scientists are mainly interested in science. So that's simply speaking. And we are not the data, the IT experts. From my background, maybe it's different with the bigger infrastructure. So I think the alliance between the e-infrastructures and the science clusters is really good, and that comes to the definition of the European Science Cloud we have developed from our science clusters view, as the E stands for consolidated e-infrastructure, the O stands for open science, and the S and the C stands for the scientific content. And this defines the roles. The contributions, I think, to the developments need to be balanced from the various points. So with that question, shall not the clusters build up the EOSC core? I would think that's a difficult experience, because we may not have the technical experts to do that. So we need to rely on the technical experts, but we know what we need. So the collaboration, the balanced collaboration, it's the big challenge of building the EOSC with from these very two different branches, getting them together. And this is still an adventure which is ongoing, I would say.
Okay. Any last words?
Just to say that I agree, and that the science clusters are probably, we have all the ingredients here, but I think we're not doing such a great job. This is my personal opinion. We could do much better linking the services that we're developing with the science clusters as the first users. And I think this was the concept behind creating the science clusters. They would be the first customers for the EOSC. But I always have the feeling in these symposia, and I've been to most of them, is there's still a mismatch there, or a detach. We're working on services, we're working on science, and we actually don't get enough linking, enforcing this. Are you using these services, or why aren't you using these services? And I think, you know, I'm a big fan of let's call a spade, yeah? We should say what the situation is, and I think we could do much better as a community. That's just my opinion, yeah.
Okay. Then I think it's about time to close this session. Thank you for your rich contribution to the debate that will continue, I hope, during the lunch. And thank you for your input and questions.